reciprocal functions. Cosecant is odd because sine is odd, right? That should be a no-brainer. Cosecant of negative theta is the negative cosecant of theta. Secant is even because cosine is even. So the secant of negative theta is equal to the secant of positive theta. It doesn't change. And cotangent is odd because tangent is odd. So cotangent of negative theta is the negative cotangent of theta. Okay? Now, let's talk about functions of the complement. Remember, when two angles are complementary, they add up to equal 90. Okay, so the complement of theta is 90 minus theta. Okay, now we know the sum of the angles in a triangle adds up to equal 180. Now, what if we have a right triangle? Obviously, one of our angles is a right angle. So the other angles have a sum of 90. That's where we get 90 minus theta is our complement of theta. So if I said this was theta, this angle is 90 minus theta. Okay? Now, the complement is leading us into some fun trig identities. Okay, let's draw a diagram to prove this to be true. If this is theta, this is 90 minus theta. And I'm calling these sides A, B, and C. What if I was to take the sine of theta? We know that sine is going to be A over C, opposite over hypotenuse. Okay. And what if I then took the cosine of the complement, 90 minus theta? Would also give me A over C. This leads into a couple of our identities. The sine of theta is equal to the cosine of 90 minus theta. And the cosine of theta is equal to the sine of 90 minus theta. Now I'll show you in a little bit how we're going to use these. But for now you need to know that you have to memorize all of these. They're very important. We also can say that the tangent of theta is equal to the cotangent of 90 minus theta. The cotangent of theta is equal to the tangent of 90 minus theta. And secant of theta is equal to the cosecant of 90 minus theta. And cosecant of theta is equal to the secant of 90 minus theta. In general, so a good way you can remember this, the trig functions of theta have the same values as their trig cofunctions of 90 minus theta. Sine and cosine are cofunctions. Okay? Now, here's another trick to remember it by. Where did the names of these functions come from? Sine, cosine, tangent, cotangent, right? The names, where did they come from? Cosine is the sine of the complementary, or the complementary, right? We have the CO and we have the sine. Cotangent is the tangent of the complementary angle, and cosecant is the secant of the complementary angle. Okay, really good way to help you remember this. All right, now let's talk about conditional equations versus identities. A conditional equation is only true for specific values of the variables, but identities, they are true for any value of our variables. That could be one variable or many variables. Okay. All right. Now, trig identities. Okay, we have a lot of trig identities. Okay, we're going to slowly get into them by proving them. Okay, but let's first talk about our rules. Okay. One, we are going to substitute an equivalent expression for any part of a given expression. Meaning that if I was to say x equals 2 and I had an equation with x in it, I can plug into anywhere in my equation that has an x. 2, we can multiply the numerator and denominator of any expression or part of an expression by the same non-zero quantity. You've heard me say before that we are multiplying by 1 creatively. Okay? So that is exactly what that means. And number 3, we can combine terms that have equal denominators. I say can, but really I mean you should. All right, so let's do an example. Example 1. I want us to show that the cotangent of x over the cosecant of x equals the cosine of x. Okay, now this is kind of a proof. We're going to do it small step by small step. Okay, with lots of side notes. Oops. So here's my side note. The cotangent of x, we remember, is the cosine of x over the sine of x, because tangent of x is sine of x over cosine of x, always, 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 and the cotangent of x is 1 over the tangent of x, which is 1 over the sine of x over the cosine of x, which is the cosine of x over sine of x. You need to remember that the tangent of x is sine of x over cosine of x. We will use that a lot. Okay? This is one side note. Our second, we remember the cosecant of x is 1 over the sine of x. Alright, so if I go up to my equation, I'm going to rewrite the cotangent of x as the cosine of x over sine of x. And I'm going to rewrite cosecant of x as 1 over the sine of x. Now I know if I have a fraction in my denominator, I multiply by the reciprocal on both the top and the bottom, canceling my sine 1 over sine x on the bottom, and canceling my sine x on the top, leaving me with the cosine of x. That's all we have to do. We just proved one of our trig identities, that this is a true statement. Okay, let's do another example. Example 2, I want us to show that the sine of x cotangent of x is the same as 1 over secant of x. Okay, so I'm going to start with my left. I'm going to say the sine of x times cotangent of x. Cotangent of x is 1 over tangent of x. Okay, now I also know that tangent of x, right, is sine over cosine, or I could just write cotangent as the cosine of x over sine of x. Okay, and my sine of x is canceled, leaving me with the cosine of x, which is 1 over the secant of x, right? We remember, side note, secant of x is 1 over the cosine of x. So 1 over the cosine of x is the cosine of x. We've now proved 2 trig identities. Okay. Now, eventually we're going to have a lot more trig identities we're going to add up. I would suggest you guys make a big list of your trig identities. On top it says trig identities and you write them out. So far we've had this whole list of trig identities and these 2 that we have just proven. And now here comes the third we're going to prove. They will start to add up very quickly, so I would start your list now. We want to show the cosine of negative theta times the sine of 90 minus theta is the cosine squared of theta. Okay. Now, again, start with this side. We remember from our original trig identities that cosine is an even function, so the cosine of negative theta is the same as the cosine of theta, and the sine of 90 minus theta is the same thing as cosine of theta, right? It's co-function of theta. So I can rewrite this term, the cosine of minus theta times the sine of 90 minus theta. That is the same as the cosine of theta times the cosine of theta, which is the cosine squared.